Okay, our recording has started. All right. Well, it's great to see everybody again. I hope you all had a great summer. We've got a wonderful program tonight. It's entitled "Bring Back the Pollinators," presented by Dave Kollen. And Dave is very well qualified to present this. He's an outreach ambassador for the Xerces Society out of Portland, which is one of the largest groups dedicated to protecting pollinators. Dave's a master, an Oregon master naturalist, and let's see if I can say this right, a master
melitologist.
Melitologist, yes. And I'm sure Dave can explain what that is much better than I could. So anyway, at this point, let's just turn the program over to Dave. And thank you so much, Dave, for being here. Greatly appreciate it.
Okay, I'm glad to do this. I'm going to go to share screen. And hopefully you can see an Excel spreadsheet, Excel, PowerPoint, and it's about to be full screen. Everything working okay?
Looks great.
Very nice.
And let me see if I can figure out how to get my little laser pointer going in case I want to use that. Yeah. I'll leave this in the corner over here. Okay, so yeah, master melitologist, what that is a person that studies bees, and that's a certification program run by Oregon State University Extension. So we go through training, and then we participate in what's called the Oregon Bee Atlas. And in addition to doing that, I also work on a couple of bumblebee atlases, the Pacific Northwest Bumblebee Atlas and the California Bumblebee Atlas. So let me go ahead and just get started here, and let's talk about pollinators. So a little bit about Xerces, first of all. Sorry, I got this dang. Forgive me, I've got to get everybody's picture off this screen because it's annoying me. There we go. There. Okay, sorry about the interruption. So Xerces Society was named after the Xerces blue butterfly. It's the first butterfly in the US known to go extinct because of man-made causes, last seen on the San Francisco Peninsula in the 40s. Xerces has been around for 50 years. And our mission is conservation of invertebrates. Why do we care about invertebrates? Well, as E.O. Wilson said, they're the little creatures that run the world. And although most of us don't pay a lot of attention, if they were to suddenly vanish overnight, we would pay attention very quickly. They're responsible for decomposition, biocontrol services. They're the base of many food chains, and pollination, which we'll talk about tonight. So Xerces works through conservation, advocacy, research, and education, the latter of which I'm doing right now. We have 17,000 members and work with dozens of federal, state, local agencies. We've helped conserve, I think the number now is something like 2.5 million acres. By working with agencies and farmers, land managers, and of course, people, individuals like yourselves that hopefully are going to go back and put some of these ideas to practice in your own yards. So just a brief refresher. It's been a long time since some of us have been in school, at least myself. So pollination, simply moving pollen from the male part of the flower, the anther specifically, over to the stigma, the female reception point, And, it's just plant sex 101 for most plants anyway. So if we look at the pollination strategies of flowering plants, of which there are roughly 350,000 different species in the world, 85% of those plants rely on insects, invertebrates, for pollination. Things like hummingbirds, bats, which you've probably heard are pollinators, believe it or not, there's an opossum that's a pollinator, make up just a fraction, a tiny fraction. Wind is a pretty big at 12%, and that's a lot of trees and the cereals that we eat. So why do we care about pollinators? Well, 85% of plants require a pollinator for reproduction. And the reason that's important, other than the fact that we like having plants around, is 1 in 3 mouthfuls of food and drink we consume are due to pollinated crops. That's a figure that's used. It obviously depends on, what your diet is individually. And in fact, that would be a larger fraction if we didn't eat so many grains. Globally, there are 1,200 crops that rely on pollination services, at least to some extent. And if we look at the market value of additional production due to pollination, so some plants will get a certain amount of pollination through selfing, but with pollinators, they get a better seed set. So if you've ever seen a corn cob that has no kernels at the end, it didn't get pollinated properly. So some years back, Whole Foods did an experiment, or I should say a demonstration, to show customers how important pollinators were. This is a produce department, just the way it is normally. And this is what it looks like after they removed items that were reliant upon pollinators. And most of what you're seeing are citrus. There's a few apples that don't need pollinators, but kind of a boring selection. They did the same thing in the dairy department. And at first glance, you might think, well, what does dairy have to do with pollinators? Well, that's what it has to do with pollinators. And so if you look at this, the driver behind this is alfalfa that is used for feed supplementation in a lot of dairy farms and other places for that matter. So alfalfa pollination to produce seed for farmers relies on bees. In addition, there's a lot of wildlife that's dependent upon pollinators. So fruits and seeds, this audience that I'm talking to now, of course, you're familiar with the importance to birds and other animals. Grizzly bears, there's a moth that's called a miller moth, and they did a study up in Yellowstone. These moths hide under rocks during the daytime in huge aggregations. And one grizzly bear can eat up to 40,000 miller moths a day when they're fattening up for hibernation. At a half a calorie per moth, that allows them to put on 20,000 calories a day just from those moths. And then, a lot of the larval stages of pollinators are bird food for nestlings especially. And so they did a study in, I think it was North Carolina, on South Carolina chickadees, not to be too confusing here. And they watched a pair just over 10 days, I think is what it was, for the nestlings to fledge. And they counted, they basically maintained people on spotting scopes. And they brought back over 10,000 caterpillars during that period of time. So it's just an enormously important source of food. And of course, there's other things besides that. They enrich our lives. So, most of us like flowers. Some of us like picking berries in the summer. I was forced to do it as a child, so maybe it's not my favorite thing. But pumpkin pie, well, that's always my favorite thing at Thanksgiving. So I want to talk now a little bit about pollinator diversity. So there's 6 main groups of insect pollinators. These are orders in a taxonomic sense. And from upper left clockwise, what we have is a butterfly, a moth, a fly, a bee, bumblebee in this case, a wasp, and a beetle. So all of these are pollinating insects. Now, however, bees are the most important pollinators out of that group. And that's a general statement. It's particularly true for the vast majority of crops. But there are, as with any generalization, there are exceptions. So for instance, the cacao plant that we get our cocoa from, those flowers rely on a fly to be pollinated. Bees don't do anything there. And figs rely on something called a fig wasp. So there are instances where bees are not the primary pollinator, but they're few and far between. I want to point out that honeybees, which if you ask most people, name a bee, that's what they're going to name, that or a bumblebee. Honeybees, they're not typical bees. Number one, they're not native, they're European or Eurasian actually. And they live in large colonies, tens of thousands of individuals. And it's just totally unlike the native bees that we have. And I just realized I skipped something here. So there's 3 distinct behaviors that bees have. They are there to collect and transport pollen. That's the one of the things that makes them such good pollinators, because the rest of those insects, for the most part, some of them are going to eat pollen, but most of them are there for the nectar. And they may accidentally take pollen somewhere, but bees are doing it on purpose. Bees forage in the area around their nests. There's something called a central area forager, and that means they will go back and forth over time to the same plants. And additionally, they exhibit something that's called flower constancy. And what that means is that when a bee leaves the hive, or wherever their nest is, they will tend to stick with a certain type of flower on a given foraging bout. Now, they will switch around a little bit, but they tend to stick with one flower as long as they're available. And the reason they do this is because they get more skilled at flower handling, and it just makes them more efficient. So one of the benefits of that is, since they're going to the same type of flower, well, that's exactly what you want to do if you're trying to get cross-pollination going. It'd do no good to go from a tomato flower over to a squash flower, like say, a butterfly might do. So this is why bees are really important pollinators. It's a behavioral thing. So honeybees, before I stop talking about them, they're very important, and especially for crop pollination. Although in the later, and say in the last 10 years or so, we become more aware of how important native bees are in addition. And there are, in fact, some crops that honeybees can't pollinate, like tomatoes. You've heard of colony collapse and things like that, I'm sure. So, the beekeeping industry, they've had their ups and downs, and they're, really fighting a battle. Hopefully, they can win this game. So going to our native bees, most native bees are solitary bees, meaning that the female lives alone. 90% of our native bees are solitary. They're very gentle. being solitary, they don't have a big nest to defend. And that makes them unlikely to sting. If you look at social bees, say bumblebees, honeybees, there are a few others that are social bees. You know, they've got a nest to defend, and some of those workers will actually take up a defensive role, and they can be fairly aggressive because that's an evolutionary trait that's evolved, and it's an advantage to them in survival, unlike solitary bees. So if we look at bee diversity in the US, or let's start out with the world. In the world, there are approximately 20,000 named species of bees and probably 25,000 total. The US and Canada, that's north of Mexico, roughly 3,600 species. Oregon, let me go through, 600 to 800. Washington is around 600 estimated. Portland, 100 to 150. And this number is probably pretty good for Spokane also, say, 100 plus species in the metro area there. And then in a single yard, if you've got a decent pollinator habitat, you could maybe find 30 or 40 different species there. These are some common Western bees that you well may have seen. I'm not going to go through this. That wasn't the intent, but the orchard bees here, they're fairly common. The metallic sweat bees, some of them are all green, some of them are striped on the abdomen. They're fairly common. And then these digger bees and mining bees, again, very common. And, believe it or not, we know very little about the life habits of these bees. And in fact, we know very little about where they are, and for that matter, how many there are in our states. And so I mentioned earlier, I'm part of the Oregon Bee Atlas. And what we do is we collect bees from across the state of Oregon, and they go into a taxonomic collection, and there's association with plants that's recorded. And so we're building a baseline to understand what we have, and that will help inform conservation decisions that need to be made in the future. So one aspect of bee diversity is just the size. If we look here, these are the largest and smallest bees in North America. They both happen to occur in California. The large one is called a carpenter bee. It's a valley carpenter bee. And the small one is a perdita. It's a mining bee. So it lives in the ground as a solitary bee. And if you just look at the difference in size here, you could fit, 3 or 4 of those little perdita inside of just one of those compound eyes on that carpenter bee. So just an enormous size difference. They come in, a variety of colors and body characteristics, for lack of a better term. So we've got really hairy, fuzzy bees like this one on the lower right. That's a fuzzy-legged leafcutter bee. That's a male. On the top, a metallic green sweat bee, Agapostemon. And then on this guy here on the left, lower left, is a nocturnal bee. Now, this picture actually is something that's in Central America, but it's such a good picture, I use this. We have nocturnal bees here in the US too, mostly in the Southwest area around, northern Texas and west from there. And if you look closely, there's adaptations for the fact that this is nocturnal, right? So it is active in very low light levels. The size of the eyes compared to the rest of the head they're very large. And these little eyes up here, they're called ocelli. They're They're not very sensitive. They're kind of light and dark detectors, but they're huge compared to, say, the ones on this bee here. And so the anatomical features of this bee give it a something like almost a 30x sensitivity to light. Another diversity is behavioral diversity in bees. So carpenter bees, which I talked about just a moment ago, they're famous for being nectar robbers. And what a nectar robber is if you look, hopefully you can see my little cursor moving around here, but if you look at this lower left bee, this is the mouth part, and it's sticking right into the bottom of this flower. The reason it's doing that is it's getting nectar directly from the nectaries. The plant would prefer that this bee comes this way so it can pick up some pollen. So this bee is called a robber because it's not going to perform any pollination service for this plant, this flower. There's something called a cuckoo bee, which I will talk about just a little bit later when I go through bumblebee colonies. That's a social parasite, cuckoo bee. There's another kind of cuckoo bee, which is a brood parasite. And brood parasites, well, they get their name cuckoo bee from the cuckoo birds. So I'm sure I don't have to explain to any of you what cuckoo birds do, but just in case I do, they're known for kicking eggs out of nest, laying their own, and having another bird, another species of bird, raise their young for them. These bees do basically the same thing. They'll sneak down into a nest, and if they find an egg in that nest, they'll kill it and lay their own egg, and that egg then will take the pollen stores that were supposed to be for another egg. Just one reminder here, wasps are not bees. When we see these showing up where we don't want them, a lot of times people say, oh, a bunch of bees came out of the ground. Well, you know, unless they're bumblebees, you're not going to get a bunch of bees coming out of the ground. And typically, bumblebee activity is so low, you're not even going to see them unless you get lucky. But if you do identify it as a wasp, don't go and spray it with Raid. Certainly not when you've got your meat on the table. But even without that, you know, wasps, especially native wasps, they're very beneficial predatory insects. I mean, we really need to keep them around. So now I want to talk a little bit about the natural history of native bees. And basically what that means is, what do they do for a living? So I want to show you the solitary bee life cycle. This is an example. The majority of solitary bees, they only spend a few weeks as an adult, 4 weeks at the most. And during that brief period of time, the female is going to go and construct a nest and gather pollen. And that's the picture on the right-hand side here. Gather pollen. They take nectar and pollen together, and they create something that's known as a bee bread, or a bee loaf. They'll lay the egg on that, and after 1 to 3 weeks, you'll get the first larval stage, and that's going to continue through various instars over a period of 6 to 8 weeks typically, and then you'll finally end up with a pupa, and it's going to stay in this stage for 8 to 9 months. And then after that period of time, we get what's called eclosure. These bees are going to find their way out of the soil or wherever they happen to be nesting, and the process is going to start all over again. Males typically will come out first, so that when the females come out, they're ready to go and do their job. And again, once the female's mated, the males, like so many male species, don't really contribute much. So they're off just living as long as they can. So 70% of our native bees are ground nesters. So the vast majority of native bees are ground nesters. If you don't pay attention, you don't know what you're looking for, really. They can look like little ant hills in your yard. And so, it's good to keep sandy soil available a little bit. I'll talk more about that later, at least bare soil. And if we look underground, these are just a couple examples of the kinds of nest structures, excuse me, that you might find. And there are dozens of different architectures that they use. So 70 were ground nesters, that leaves 30%, and those are tunnel nesters. They will take, beetle tunnels, anything like that, hollow or pithy stems in a shrub, that'll work fine for them. On the right-hand side here, you see a couple of examples. This top is a tunnel that is filled with bits of leaf. That these pieces here are all individually cut by what they call a leaf cutter bee. These are cut to size, basically, and they line their nest cell, and they'll create that bee loaf that I talked about. They'll lay an egg on top of it, they'll seal it, then they're going to make another one and another one. When they get to the end of the tunnel, they will create a plug, a very dense, chewed up bee leaves. On the bottom here, we see the same thing, but this is some kind of a mason bee. So the partitions here are going to be a kind of a muddy substance. So if we look at the various nest materials, as I said, they'll use leaf pieces. So this is a leaf cutter bee, a Megachilidae family, taking a piece of leaf down into this hole. They'll use resin, soil, various things. Some of them, not very many, but there's a few that'll actually use pebbles for their nest. There's a family called Osmia, and they're part of the leaf cutter family, the Megachilidae, and they're known to just be, they'll take advantage of anything they can find. Now, this particular bee is in Europe, but it's a perfect example of the fact that they'll use anything, basically. So this is using a snail shell. And then there's some carder bees that will use plant hairs. They're called trichomes, and they scrape these off the leaves. And I've got some coastal buckwheat in my yard, and I've been watching this past summer and watching these bees go and scrape these hairs off, and they roll them up into a little ball and hold it under their abdomen, and they fly away and they create these little nests out of those things. So I said I'd talk about the bumblebee life cycle. So bumblebees, they're colonial. These colonies can range from, anywhere from 50 to, 200-300 would be big. And that would be only certain species that would get that large. You have to have time to grow that large. Bumblebees, for the most part, they start out overwintering. So I'm going to start here. This bumblebee is hidden under leaves in what's called a hibernaculum. In the springtime, when the temperatures get right, they'll come out and they'll start foraging and building up, because they've used a lot of their fat reserves over the winter. So they're getting their energy back. And then she's going to go, they're technically called gynns at this stage instead of queens. She's going to go find a place. They like abandoned rodent burrows and maybe, hollow places and logs. Some species, it is species dependent. Sometime around early summer, she's going to have collected enough honey and I should say nectar and pollen that she's going to lay eggs. She's going to incubate them much like, it is interesting, it's almost bird-like because she's got a spot on her abdomen that is hairless and allows her to do a better job of incubation. She's going to stay with these eggs and larvae until they really hatch out. So in 5 to 6 weeks, she's going to start to have her first workers. And at that time, she'll no longer leave. The colony is going to continue to increase in size. And somewhere around 10 to 15 weeks, reproductives are going to occur, are going to appear through something called colony changeover. So that's when she stops making worker eggs and starts laying reproductive eggs. And then they'll mate, and the new gyne, okay, so again, we don't call them queens until they actually have a nest. New gyne is going to find an overwintering place after fattening up, and the process will start over. So one thing I want to point out, if we looked at solitary bees, let's say that she had 10 of those cells in a row. They'll typically lay, 20 to 30 eggs, these solitary bees. And so if 3 or 4 of those are lost, she still has what, 15, 16, 17 left. And it's not a big deal. Well, if we look at a bumblebee colony, this thing has to survive until 10 to 15 weeks. That's the reproductive unit of this colony, is getting these reproductives out. And if it falls prey to an animal, or they run out of flowers or something like that, then the reproduction rate on this colony is 0. Bumblebees, they like, as I said, old rodent holes because they, old rodent nest already have insulation. Bumblebees don't drag insulation into their nest, so they like to find a place that's got some insulation. They like to have it a little bit overgrown. If you've ever come across bumblebee nests out in the wild, one thing you'll notice is that the workers will drop down. They like to drop down in some tall grass or some herbs like this, and then crawl along and get over into their hole. They don't like an exposed hole because predators can see that too easily. So now let's talk about habitat needs for any kind of bee. We've got to have flowers. That's where nectar and pollen come from, obviously. And bees will drink nectar from any accessible flower, as will all those other pollinators that I pointed out real early on. But bees can be very particular about where they collect pollen. So, and in the extreme, there are some bee species that will only go to one species of plant. And as you might guess, that could be very problematic if something happens to that species. Either one, because the plant is not going to be pollinated if the bee goes away, and the bee isn't going to survive if the plant's not there. So these are especially fraught relationships, and makes them very sensitive to environmental fluctuations. But I'd say the majority of bees are generalists. So if we look at flowers, one thing to be aware of when you're planting your own yard is one size doesn't fit all. So I've got some pictures here of bees, and this is an andrena. It's a short-tongued bee. It would love to be on this flower here, and it would hate it if it had to do something with this, because there's no way it can use that flower. And I can't get into too much detail here because, well, I'm on the clock. So, but I'll just point out one other thing. If we look at this bee here, which I think is probably something called a habropoda, very long tongue, and that long tongue, now that will allow it to get into this aqualagia, maybe into these penstemon here. This is an Erica family, something like a, the name Salal or something like that. I don't think you have that up around Spokane, but say, manzanita, etc. So, bees require flowers that match their tongue, I guess is the message I'm trying to say, give you. And there are differences in tongue length that make that important. So now I want to talk about threats. So the threats that we face, or they face, we all face maybe, habitat loss is one of the big two. I'm not going to talk about it because, well, you know when you see it, right? It's a visceral kind of recognition. Not everybody recognizes this as habitat loss, but it is. As far as a bee is concerned, both of these are just worthless, right? Might as well be a bunch of rock. Second biggest thing is pesticides. And in the US, we apply over 1 billion pounds of pesticides per year of various types, right? Pesticides are all your insecticides, fungicides, herbicides. And one of the big problems is that we use pesticides in an urban environment, not because they're needed, but for cosmetic reasons. And, there are a lot of people that if they find a hole in their leaf somewhere on a plant, they go running over to some garden supply place and, begging for something to kill whatever bug's doing that. And the problem with that is, these pesticides, they wash off, they get into the waterways, and they cause a lot of harm. They can stay in the lawns and things. They can get on your kids, they can get on your pets, etc. And what's really, ironic in some sense is that, most of us, if we hear pesticides, we're thinking, oh, well, it's the farmers that are doing this to us. Well, they've done studies, and there's an area in southern Puget Sound, a suburban area, and they did a study, and the people were using more pesticides per acre in that suburban area than the farmers were in most agricultural areas. And that's because farmers know how to apply it. They've been trained. They have to be trained. And it's a cost to them, and it affects their bottom line, and they're not going to use more than they have to. Some of you probably remember back in 2013 during Pollinator Week, ironically enough, there was a big bumblebee kill off in Wilsonville, Oregon. And that was due to some systemic pesticides that were applied to linden trees in a parking lot. And I know the guy that did the study on this, and he says that conservatively, there were something like over 100,000 bumblebees lost in that incident. And they were able to determine that through DNA analysis, because they can look at DNA similarities and kind of get a guess on how many different, not just species, but how many different colonies are represented there. So another thing about pesticides that many of us don't hear about are the sublethal effects. So we know when we go and spray a wasp with Raid and we watch it wiggle and die, okay, that's a lethal effect. But what happens when a bee picks up a little bit, but not enough to kill it? Okay, well, that can affect their reproductive success, impaired nest finding ability, and reduction in offspring. The larvae will grow slower with certain pesticides, exposure to certain pesticides. The immune systems are impaired. And then finally, and this is really, crazy, it impairs their learning. So they're not able to fly as well and navigate either back home or to forage sources. So these are things that are really important, but that they're not in any of our pesticide testing protocols. So I want you to just look at this for a few seconds. This is the safest amount of pesticides. Store that away. Okay, it's not a little bit, it's 0. Now I want to talk about pathogens and introduced species. I got to pick it up here. But these are another threat, not as big as the last two, but if we look at, say, introduction of parasites by non-native bees, such as honeybees, what you see on this honeybee in the picture right here, that is a Varroa mite. You've probably heard of that, Varroa destructor. And one of the problems with this mite is it can carry something called deformed wing virus. This picture is a bumblebee that has suffered from deformed wing virus. And in case you can't guess, these two little stubs here are the wings. Okay, so it's obviously not going to fly very far. And these are actually have been transmitted to native bees through vectors off of honeybees. Loss of native forage plants due to introduced species. So in the Pacific Northwest, at least the western part, garlic mustard is a big problem in some areas, and it just outcompetes other plants, and it's not a good forage plant. We have introduced predators, such as this European paper wasp here. They love eating our native caterpillars, and that's, taking food away from our natives, and we don't like that. And then finally, if there's enough introduced species, you can start having resource competition. And in fact, there are areas where this occurs with honeybees. If you have commercial operators that go and drop, 500 hives out somewhere to allow the bees to just roam the neighborhood, so to speak, and get their nectar stores built up, honey stores built up. If there's too many of them in one spot, it really leaves nothing for the natives there. So the final threat is climate change. And one of the things we see already occurring are rain shifts. So in general, species either have to move to higher altitudes or higher latitudes so they can find themselves in a kind of a temperature regime that they're used to. And if there's room to move, that's fine, but there has to be habitat to move through. And that's where our problems are, because we don't have much connectivity, where we've got these kind of mosaics of, good habitat among areas that are terrible. Another thing is something that's called phenological mismatch. And so what I have here in the center is called a phenology wheel. And I'm going to start this thing running and then explain a couple things. So these are the months ticking by, and the flowers are just representing, flowers. This is all made up. And we're going to stop here in May. And I want you to notice these are bumblebees over here, and these are the flowers that are suitable for them. Okay. This little green one is a specialist bee. And remember, I talked about specialists. So this one can only use one flower. It's this orange flower. So the bee emerges in the same month as the flower. That's not an accident, right? It has to be that way, otherwise they don't survive. And we'll let this thing go, continue on throughout the year. And what we see is everybody's happy. So bumblebees have had flowers during the whole time they needed, and our specialist bee did. Now I want to go and show what happens when these things, where we have phenological mismatch. So we're going to let this thing run to May again. I want you to notice we had a flower a month earlier. That kind of makes sense with warming, right? We are seeing some flowers shift out 2-3 weeks. That's not a problem because the bumblebees didn't come out until February, and they have had flowers all along. But okay, where is our specialist bee? Okay, oh, here it is. Now it's out in May again. Where's its flower? Well, since you can't answer, I'm going to tell you, its flowers back in April. And what is the problem here? It's gone in May. So what does that mean? It means that next year, this bee is going to be gone. And this is a very serious concern. And that's why these specialist bees are in such jeopardy right now. Now, luckily, for the most part, what we're seeing is that both the emergence times and the flowering times are moving earlier. So we're not losing a lot of synchronization there. And then I'll just let this thing finish out. And now I want to talk about conservation. So we have 4 principles we follow at Xerces. Number 1, provide appropriate flowers and host plants. No pesticides. Provide nesting, egg laying, and sheltering sites, and then spread the word. That's kind of what I'm doing. Want to go talk about honeybees again briefly. Some people think that if you go and put in a hive of honeybees, somehow that helps bee conservation. Well, there are reasons for keeping honeybees, but bee conservation is not one of them. Bee conservation means providing adequate habitat for bees, and that's it. So what is good habitat? Well, good habitat needs to support the entire life cycle, and bees need all of these things here. We've talked about this. They need nest sites, they need secure nest sites. They need flowers for foraging, and they need a pesticide-free environment. That's what constitutes good habitat. Want to talk about habitat mosaics. You don't have to have everything in your yard. This mosaic here is composed of tiles. And as long as all the tiles are there, doesn't matter if they're in one yard or strewn across 3 or 4 yards or a nearby park. So we look at a bee's eye view of a neighborhood, and I'm not going to go through this in detail, but you'll see up here in the upper right, there's a ground nesting bee. And its flight path is just an example of where it might go. And these are some things it might find. But the bottom line here is that it's finding all the forage it needs across the season, and it's finding nesting sites and sheltering where it needs it. And that's it. Any one of these homes can be missing something. As long as it's there in totality, no big problem. These are some other examples of partial habitats, some better than others from a bee's perspective. But if if this is across the street from you, you can kind of scope it out and say, well, if I do this, then we have everything we need. Appropriate flowers and host plants. So plants bloom everywhere, but not all flowers help pollinators. And hearing me say that may seem a little weird. Why wouldn't all flowers help pollinators? At least if they have nectar, right? Well, I'm going to talk about that in a bit. So if you're looking to increase your forage, remember when you do that, don't yank something out before you put something in to balance out, and then presumably add to that so you get better. Okay? And always remember, locally native plants are better. I'm going to say this over and over because it's really important. Native plants are better. So when we look at our choice of plants, there's just a ton of things we have to worry about, right? What colors do we want? What kind of structural diversity? Not only the flower diversity, the shapes and that, but just the 3-dimensional structure in our yards, the texture of the plants, etc. Bloom period, this all important thing. Do we want to use natives or not? Drought tolerance, that's an issue for you, I know. And then what's the overall landscape context that we're working in? Native is best. So here are some examples of plants that bloom late winter, that's over on the left, all the way into late fall. So if you recognize these, this is some willow down here early on, and we get all the way over into the fall, and we've got aster, and I think this is grandelia of some description down here, gumweed. And that's what we want to have. garden plants, some people call them exotics, non-natives, whatever you want to call them. They're okay in a formal landscape when they're chosen carefully. You know, if they provide nectar, then they're of some benefit. Let's go back to this, not all flowers are beneficial. Some modern cultivars have been intentionally bred to have more and more petals because people find this fullness pleasing, at least some people do. And this happens just because there's mutations basically in the stamens, and the stamens turn into petals. So people find it pleasing. But what do you think a bee finds this thing as? I mean, if I was a bee and I was trying to get in there and get some nectar, I'd say, what the heck am I supposed to do with this thing, right? There's nothing. So these are called double flowered varieties, and really avoid them at all costs if you can. Another pet peeve is butterfly bush. A lot of people like them. They're very invasive though. They're on the most invasive list of the Pacific Northwest Pest Plant Council. And even though they're called butterfly bushes because of the nectaring, they're only a larval host for 1 out of 725 butterfly species in the US. So really pretty worthless because you can easily find a native nectar providing plant to replace this thing. And then tropical milkweed, which is Asclepias curassavica, you can read it there, curassavica. That probably not a problem in Spokane because of your low temperatures. And so I'm not going to really talk about that other than to say, you know, if you can get something that's a local, regional, native milkweed, do that instead. Lawns. There's something called an eco lawn, and that's something that you can put in, and they can look pretty nice. If you look at this upper picture, I really like that look. They're selected to keep that kind of low growth, though you don't have, so you don't have to mow them all the time. And then the other thing you can do is apply benign neglect, and sometimes this depends on, you know, homeowner association rules and such. This is a picture of part of my front yard, and when I let things go in the summertime, and it actually gets fuller than this, the lawn does, of flowers. And, you know, this time of year, my wife hates this. She says, you know, what are the neighbors going to think? And, you know, I say to hell with the neighbors, I'm worried about the bees. And so, you know, I let it go. And it doesn't get much higher than what it is right there. And I think it's fine. And I don't have an HOA to worry about. So let's talk about these pesticides again. Avoid using them, minimize the use, be warned. Even if you follow the instructions, there's limited protection for native bees because of the testing protocols that are used by the EPA. Now, I'm running low on time here, so I'm not going to dwell on this. Also know that organics are not the solution to the problem, organic pesticides. They're better than synthetics because they go away faster, but they're still pesticides. They still have adverse effects on native bees. They still have sublethality to worry about. Better to use some kind of an alternative, beneficial predators, parasitoids, as it'd be like wasps and things. And if you put in good habitat, you're going to support a lot of different insects, a lot of different invertebrates, and you get this kind of natural ecosystem going. And I never use pesticides, and I have no pest problems, except when I say try to start out a new sunflower or something like that, and I got to watch the slugs for a while. Just neonicotinoids, I talked about that bumblebee kill off. Some nurseries will have plants available that are have been treated with systemic pesticides. This is really a bad thing because they come home with the plant. They get into the tissues of the plant. They can get into the nectar. If they're woody plants, they can stay for months or years. in that plant. So what you should do when you go to your friendly independent nursery is ask them, tell them I'm looking for this or that. Are these treated with systemic pesticides? If it's a good nursery, they should know, or they should find out for you. And if they say, well, I don't know, say, well, I'm not going to buy any plants from you. I really want to, but I'm not going to do it because it's more important to me not to have systemics in there. And, if they hear that from enough people, they'll change their ways. So you want to provide nesting, egg laying, and sheltering sites. That's the third one of our principles. Bee nest sites, we talked about tunnel nesters, ground nesters. So if you can retain some existing snags, as long as it's not dangerous, that's good. Shrubs with hollow stems, bare ground for ground nesters. If you have trouble providing bare ground, you can always get a little helper like I have. He creates a lot of bare ground for me. This is in my backyard. This picture, this is about 12 inches by 18 inches. And you look at that and you think, okay, so, well, these red circles are all mining bee nests. So they're small little ground nesting native bees. I didn't even realize they were there until I saw one flying around. I was doing some weeding. And so I said, wow, interesting. I mean, I do leave ground intentionally, but this wasn't part of that area. So tunnel nesters, you want to pick some plants with pithy stems, bush honeysuckle, this stiff goldenrod, and there's some other things there. Natural areas are good because there'll be some of these kind of pithy stemmed things growing there. And then on the far right is a little carpenter bee. Not that it's related to that big giant head that I showed you at the beginning. This is called a small carpenter bee, Ceratina. And these things are, half an inch long, little ones. And this is where it nests, is in a little hollow stem like this. You can make your own. I'm sure you've seen these nest blocks at nurseries. There's instructions online for how to do these things. They do work. And if you look closely, you can tell what's nesting. Above, we see green bits of leaf. So what's that? Leafcutter bee. Down below, we see mud, mason bee. It's more than just bees that'll use this kind of a structure. This grass is being carried in by a solitary wasp, and they're great little predators. You want to have those around. Bumblebee boxes, you can build these things. They're at the most, you're going to get, 10 or 20% usage rate, and probably, more like 10 or less. Nice project if you've got kids and you want to do something. Larval host plants. You like butterflies, you want to be thinking about this. They're regionally specific. They vary with the butterfly, right? And there's flowering and non-flowering varieties. Skippers, they use a lot of grasses. So there's a place, BAMONA, Bamona, Butterflies and Moss of North America. And if you go to their website, they've got a huge amount of information for you. Leave the leaves. They're beneficial for a lot of reasons. And leave the leaves means over the fall. Remember that hibernating bumblebee? There's some butterflies that'll use that, and other invertebrates that you want to have. Spread the word. You don't have to do what I'm doing, but there's other ways that you can get involved and show people that, hey, it's really important to think about our pollinators. You become an advocate. Darn it. X-Kids is something, if you go to the Xerces website, you can find out about this, but it's for kind of 3rd to 6th grade kids, and it can be used in a classroom. It's a booklet. It's actually like an instruction manual. And you can get involved in various aspects of community science if that's something that you'd like to do. There's Bumblebee Watch, I mentioned that earlier. There's a Western Monarch count. You can go to bringbackthepollinators.org and sign the Pollinator Protection Pledge. There's 4 principles you agree to. And you can get one of those nice little habitat signs like I have. If you go online, there's a huge amount of resource. And I just want to point this out. We're just about wrapped up here, so please bear with me. If you go under resources, so we're talking about Xerces.com, go under resources, Pollinator Conservation Resource Center here. You've got all these categories, and if you click on these, they all expand. So you can go to your region. Some of these resources are more than one region, and there's just a wealth of information there. There are a lot of really good books that Xerces has put out. I want to talk about these. If you're a social media type, we're everywhere. We're a donor-based member organization. So, we'd love to get new members and, donating members even better, but you don't have to donate. You can sign up for emails and stuff. And that's it. I'm sorry, I kind of run a little bit late there. If there are any questions, I'll be happy to answer.
Okay, I've got one question. I've had a lot of noxious weeds like bug loss, and I pulled out tons of it. But then you've pulled out all of these flower producing plants, and what do you do to replace it? And are the bug loss providing more for pollinators than the problems they're causing?
So I'm not familiar with that. I mean, I've heard the name, okay, but what I'm not familiar with is that an invasive? Is that a non-native species?
It's considered a noxious weed.
Okay, okay, so if it's considered noxious, that's a particularly bad name. So you should probably get rid of that. Now, I've got a chart. I need to start adding some supplemental material here, but anyway, I've got a longer, believe it or not, I've got an hour and a half version of this thing. One of the things I do is I create a chart of kind of bloom by month, what I have. And so from an overall perspective, kind of get an idea of what coverage do you have right now. And remember, for bumblebees in particular, we want to have coverage from kind of late winter through to the end of fall. And even those solitary bees, they emerge at different times of year. So it's not just for bumblebees. And so if you can kind of look at your yard and say, okay, yeah, this blooms here, so I got pretty good coverage. And the bug loss is providing coverage in July and August. And what if I yank all that out and find a nice little annual or perennial native that provides flower during that same time period? That's how I would approach that.
Okay, thank you. Are there any other questions?
Yeah. Did you see that one, Lundell?
Yeah. Someone said they've heard domestic honeybees and native bees compared to cattle and elk. They're not inherently bad, but they're not wildlife and can compete. Do you agree?
Well, so there's certainly not bad. And they can compete. I mean, basically, this is true. And it's all about the context. Okay. So, in an agricultural setting, where, you've got, say, an intensively farmed area, probably, unfortunately, there's not going to be a whole lot of native bee competition there. But on the other hand, if my neighbor next door went and put in a hive of honeybees, that's their choice, obviously, and I wouldn't say anything about it, but I would be very dismayed because I've worked really hard to get native bees in my yard, And, you know, when you do a starter hive, you get 2.5 to 3 pounds of bees. And so that equates to somewhere around 10,000 bees, workers, and a queen. And half of those will stay in the nest roughly, and half of them will be out looking for flowers. And so if all of a sudden you had 5,000 honeybees right next door, what do you think would happen to the flowers in your yard? And that's, you know, that's one way to look at it. But, you know, everyone's got the right to do what they want to do. And, you know, if they want to, you know, have a hive, then, but what one thing, you know, and I've heard this said before, if you want to help bees, you know, you could think about putting in a hive. Well, for gosh sakes, don't do that. Not to help bees, because you're not going to help any darn bees doing that. If you want to put it in for honey, well, now that's a different thing. That's up to you. So, you know, it depends on the context. They can be detrimental to our native bees, but they can coexist in other areas. And they've done studies showing just that. So, you know, and it has sometimes to do with, you know, when does the forage start getting really scarce? Tends to be towards the end of summer, right? And so you can get times when there's a lot of competition going on. That's the best that I could do to answer that.
I
I have
Oh, go ahead.
real quick question. You said that some bees are particular to certain plants, and I have a vegetable garden, and my pickling cucumbers are all covered with bumblebees. They are not honeybees. And I live up in an area of the county where there's a lot of honeybees, a lot of domestic honeybees, but these are not honeybees. They're bumblebees. Are they keying in on a plant?
Okay, so yeah, so there's a family of bees, a genus, I should say, of bees that are called Eucera, and they're called squash bees, and they pollinate plants in the cucurbit family. So that's your squash and cucumbers, and those bees look like a lot like a small honeybee, but you're saying they're definitely bumblebees, right?
Yeah,
Okay.
they're huge.
So
I don't know how they fly.
yeah, well, they fly. They're pretty good flyers. So yeah, I've seen them in squash because I've participated in these squash bee surveys where they want to see how they're expanding. Oh yeah, they're not as far north as Spokane. I was going to say they've only gotten into Southern Oregon. Now, I shouldn't say that they're not in Spokane because I don't know that for sure. I know out this far west, they've only gotten into far South Oregon. And so I participate in looking for them. But last year when I was doing that, there are bumblebees. Yeah, you'll find bumblebees. I mean, if the bumblebees, especially the males, this time of year, they only want nectar. They do not go after pollen. Squash pollen is hard for some bees to digest. And that's why this specialist group called squash bees, they are adapted to it. And that's why they frequent it like they do. But you'll find others that will take nectar. And yes, I've seen bumblebees on them before. One thing you can do, which is interesting, the male squash bees, if you have any, when you get a closed up flower, if you go first thing in the morning and you gently squeeze it, if you feel a little bit of buzz, that will be a male squash bee in there.
Thank you.
I was going to mention on the Xerces website is an awful lot of information. It's a little disappointing that for areas the west side is covered. It's, you know, the moist part of the state has a lot of specific information. Eastern Washington is, you find it wherever you can. You know, we're somewhat mountain, somewhat western, but anyway, lots of information. We'll have to do our homework.
Yeah, so, you know, since Spokane is technically in the Pacific Northwest, you know, what I would do, because I'm on one of those border areas too, right? I'm really in the California, Northern California floristic province. And so what I would do when you go to Xerces is, you know, you can look at the Pacific Northwest, but then also look at that next region. I think, I don't remember, it's called Intermountain region, and see what's there, because there you're going to find some stuff that maybe is more suitable for your area. And then also that 100 plants for the bees goes into a little bit more regional specifics there. Excuse me, just choked. The Washington State University Extension may have some guides for the eastern areas in Washington.
Ah, yes. Good call. Let's see, and I noticed in the chat section that Donna Burt asked, how does the forest fire smoke affect the bees?
Well, you know, this is an interesting thing. I don't know that there's ever been a real scientific study done, but I can tell you anecdotally, I think 3 years ago, maybe 2, we had a fire that was really close to us. I mean, really close. And I had a lot of bumblebees. I had a nest in the yard at that time. And so I had tons of bumblebees. And, you know, as I said, the males, they just hang around after they're done mating. They'll hang around until the first frost or something kills them off, or they run out of flowers. And so, you know, more than half the bumblebees in my yard were males, and in the front yard picture I showed you, I might have had, you know, 20, 30 bumblebees at one time in that lawn. And then we got this really heavy smoke for, I think, 4 or 5 days, really heavy smoke from this fire. And when that smoke cleared, I didn't have a single bumblebee. Not one. None of the males. I still had some of the gines, and they may have taken cover or something like that. I don't know. Males stay out. They never go back in the nest. Once they leave the nest, you'll find them overnighting on shrubs and in flowers and stuff like that. So they're exposed to the smoke. Yeah, so it's not good. It's not
Unfortunately,
good.
there's not much we can do about it either.
No. And you know, they use smoke in for honeybees, right? To calm down the honeybees, they use a smoker. So it definitely has an impact.
I would like to make an announcement for those who are still with us that next month we plan on doing a hybrid meeting, and some of us will be meeting in person at the Hive, which is part of the library system, and it is located at 2904 East Sprague. So if you are able to, please join us there, and we will be starting at 6:30 instead of 7 due to restrictions on how late we can stay. So please think of joining us next month in person.
Okay, thank you.
Yes, thank you so much, Dave. That was a wonderful program, and hopefully everyone will do more research and plant more native trees, shrubs, and flowers.
Yeah, good. Well, thank you for the opportunity to present. I always enjoy doing this. More people that understand some of the basics behind, conservation of pollinators, the better we are.